So when solving, plug your x value back in, at least to the denominator. If any of your denominators equal 0, it's a no-go. Now, I'm going to show you an example to begin with, and I'm going to talk about like a strategy we can use to make the equation a little bit easier to solve. There are multiple ways to solve the equation today. Well, the method we are going to use is what is considered like the most efficient method. And efficient means fastest, less work, okay? The best way to get your answer. So that's what we're going to talk about today. If you want to try other methods, you can, but I will always use the new method. So I'm going to show you an example to start with, and this is going to be my first example. X plus 4 over 2 plus x squared minus 5x plus 8 over 2 equals 9 over 2. And there are a couple of things I want to talk about in the beginning. One of them is, what about this problem might seem intimidating to some people? You know, it's kind of hard to put yourself in other people's shoes. But if someone just randomly was shown this problem and asked to solve, what might be intimidating? Faith? Oh, there's 3 separate fractions involved instead of just 2. So like if I just gave you a fraction equal to another fraction like on Friday, I'm pretty sure at some point we all would have come up with cross multiplying because we know how to solve proportions. We spent a whole chapter doing that in geometry. But this one, we're not set up for cross multiplying. I can't just cross multiply those 2 that are right across from each other on the equal sign because nothing happens to the other fraction, x plus 4 over 2, and something should happen to that other fraction. Okay, so it might be intimidating that there are more fractions. Anything else you find intimidating about this problem? Or you think someone else might find intimidating about this problem? A couple other things people in other classes have said is that there's an x squared. Okay, so when we see x squared and x, we know we might have to factor or we might have to quadratic formula. Okay. And the big thing that I'm looking for there that in my experience as a math teacher really sort of like intimidates people is the fact that, sort of going along with what Faith said, there are 3 fractions. So I'm going to talk about a method where, wouldn't this be nice if we had an equation with x's and x squareds, but we didn't have any fractions anymore? Most of us would feel a lot better about the equation if there weren't fractions. So one method I can use is, notice that all of your denominators are the same, and they're all 2, right? So what could I multiply by my equation by to make all the denominators disappear? Just multiply the equation by 2. If you multiply the equation by 2, then that 2, if you multiply the whole equation, it would distribute to all of the terms. So it distributes to my first fraction, it distributes to my second fraction, and it distributes to my 9 over 2. I'm going to write this out. It would be 2 times x plus 4 over 2 plus 2 times x squared minus 5x plus 8 over 2 equals 2 times 9 over 2. That's what happens when I distribute that 2. If I say I'm going to multiply the whole equation, it will go to every single one of those terms, separated by a plus or a minus or an equal sign. And then what happens to like 2 over 2? Cancels out. So I can go through and I can say, well, there's no more denominator of 2. Denominator is gone. Denominator is gone. And what I'm left with in the numerators x plus 4 plus x squared minus 5x plus 8 equals 9. Well, it requires some work to clean up. I should combine like terms, and then because I have x squared and x, I'm going to try to factor it at the end. That one, if I showed that equation to people, a lot more people would be willing to try and solve this equation than my original one, because it doesn't look like fractions anymore. Okay. So we're going to solve. This would be x squared minus 4x plus 12 equals 9. Combined to my like terms on the left side. I want to try to factor because it's x squared and x, but before I do that, I have to make sure one side is equal to 0. So I'm going to subtract 9 from both sides. That gives me x squared minus 4x plus 3 equals 0. And then I think, do I have factors of positive 3 that can add to make negative 4? Negative 1 and negative 3. If they're both negative, x minus 1, x minus 3, they'll multiply and be a positive 3, but when I add them, negative 1 plus negative 3 is negative 4. So my two answers for x are positive 1 and positive 3, the opposite of those factors. Remember, I should plug these back in to see if they make any of my denominators equal 0, but this problem is probably easier than all the ones we'll be doing today, because in the denominator it's all 2. So does it make any of my denominators equal 0? No, they're both solutions. They both work. Today we're going to use this method of trying to cancel out the denominator so that we can solve. It's called the LCD method, meaning the least common denominator. If you multiply your whole equation by the least common denominator, you'll get rid of all your denominators. And then that will be exciting because we won't have to have fractions anymore. Let me show you a second example. I think I need to add a 2 on this one. I'll look and see if that's correct. I changed something about this problem. Can anybody tell me what I changed? I made it a little bit more challenging. All the denominators are not the same. So in the last example, all the denominators were 2, and we just say, well, let's multiply the whole thing by 2. And if I multiply the whole thing by 2, then all the 2's will cancel out, and I won't have fractions anymore. Thank you. You're welcome. So I'm going to rewrite this, leaving myself a little bit of space here. When you're doing your homework, it'd be really nice if you kind of spaced out your terms like this. But we want to think along those same lines. We're just going to have to tweak our method a little bit. What would I have to multiply the whole equation to make this first denominator of 2 go away? I'd have to multiply the whole equation by, to make it go away. Don't think about common denominators, think about canceling it. You'd have to multiply it by 2. So let's multiply everything by 2. It's just like I did where I say, I'm going to multiply the whole equation by 2, so every single term gets multiplied by 2. Now, does that make my denominator of 2 cancel out? Yeah. 2 over 2 goes away. And on the other side, 2 over 2 goes away. Does 3 go away? No. So I go back into what I'm looking at and I say, what would I have to multiply that middle fraction by to make the 3 disappear? 3. You just got to multiply by that factor that's in the denominator. So let's multiply everything by 3, because I can't just multiply the one part by 3, right? That would be violating like the golden rule of algebra. What I do to one side, I have to do to the other. So if I'm going to multiply the middle fraction by 3, I have to multiply all the fractions by 3. That's just sort of like keeping that golden rule. And that cancels out my 3. Check out your denominators. Is there anything left? No. So now what you do is you just go up into the numerator and you do the multiplication of what's left over. So like in this first fraction, I have a 5 times 3, which leaves me with 15. Plus, in the second fraction, I have 2x times 2, which is really 4x. Equals, over on the other side, I have x squared times 3, which is 3x squared. And now I would do the same thing that I did before, make one side equal 0. I'm going to subtract the 15 and subtract 4x from both sides. Those are not like terms with the 3x squared. So I'm going to get 0 equals 3x squared minus 4x minus 15. And then I would have to try to factor that. If I couldn't factor it, I could do a quadratic formula. This one does factor. It's a little bit more challenging because it doesn't have the 1x squared. Most of our factoring in chapter 7 has been 1x squared. This time we have 3x squared, so we're going to have a 3x and an x. And then what I have to do is I can't just look for factors of 15 or negative 15 that add to make negative 4, because one factor is going to get multiplied by 3 and one of them is not. So I'm just kind of, I play a game of guess and check. What are some factors of 15? 3 and 5. So I'll just plug them in, 3 and 5, and I'll see if my outside and inside terms will work. 3 times 5 will give me 15. 3 times x will give me 3x. Will 15x and 3x make 4x? No. So I don't want a 3 and a 5 there. I could try switching them, 5 and 3. And then I redo my outside and inside terms. 3x times 3 is 9x. 5 times x is 5x. Will 9x and 5x make negative 4x? Yeah, if 9x is negative and 5x is positive, so this will be minus and plus. And then if I set those things equal to 0, x is equal to negative 5/3, and x is equal to 3. Now again, I haven't done anything that has a variable in the denominator, so it's going to work. They're not going to be extraneous. But if any variables are in my denominator, I have to plug those x's back in and make sure that my denominator doesn't equal 0. Okay. We're going to do some examples where I'll let you think about things a little bit longer that have x's in the denominator. Okay, I know I factored that one really quickly. But I just wanted you to see how we're going to kind of work around this. We want to cancel denominators today. We are not going to cross multiply. We're going to cancel the denominator so it doesn't look like a fraction anymore. Okay. So in your notebook, let's write down what we should do if we have something that looks like a fraction plus a fraction equals a fraction. And that plus could really also be a minus. could be a fraction that's being added with another fraction or being subtracted with another fraction. Also note that any of those fractions could be whole numbers, like 5 is really 5 over 1. So those are still considered fractions, even though they might not look like one immediately. Okay. In this case, instead of cross multiplying, we're going to use the LCD method. And if you need to write this in the margins of your paper, LCD stands for least common denominator. The least common denominator. After we use the LCD method, we're going to solve for x, and we're also going to check for extraneous solutions. Just to clarify, so you can be thinking about this as you work through a problem, your main goal is to eliminate all denominators. You will cancel all the denominators using the LCD method. If you do not cancel all the denominators, then you haven't used the LCD method yet. Okay, so if at any point your problem still looks like a fraction, you haven't done step 1 right. Here's an example with x's in it, okay, in the denominator. So this is more tuned to like what you're going to see in your textbook. 5 over x plus 7 over 4 equals negative 9 over x. And when I write this down on my paper, if I'm doing my homework, I leave myself a little bit of space. 5 over x plus 7 over 4 is negative 9 over x. That space that I give myself allows me to do all my multiplication, okay, instead of like trying to cram stuff in and everything gets really messy. Okay. I suggest doing it like this. Take one denominator at a time. Okay. Let's start at the first fraction. It's 5 over x. What do you have to multiply that fraction by to get rid of the denominator? You must multiply by x, right? Whatever's in the denominator, you have to multiply by that to make it cancel out. So we're going to multiply by x. If we multiply this term by x, we have to multiply all the terms by x, so that we're really multiplying the left side and the right side by x, and it's distributing to everything. We're changing the way it looks, but we're not changing what it is. I usually take a minute to see what cancels out. So the x and x will cancel in the first term. And if I look through my problem, x and x will cancel on my last term. Have all my denominators disappeared? No, so I still need to multiply by 4. So I'm going to multiply by 4. And what I do to one, I have to do to all. So I'm going to give that 4 to all 3 terms. And that's only going to cancel out the 4 in the middle term. Now, multiply and write whatever is left over. So in that very first fraction, you have a 5 times 4. What is 5 times 4? 20. Plus 7 times x, 7x, equals negative 9 times 4, negative 36. Compare your first equation to your new equation after LCD. Which one do you want to solve? You want to solve the second one, right? You'd be so much more happy if our whole test looked like the second equation. That's one that you know how to solve. So our goal with the LCD method is to turn those ugly fraction equations into nicer equations that don't look like fractions. What steps would you follow to get x all by itself there? Subtract 20 and divide by 7. So we get x equals -8. Thank you, Damon. Now you should take that x equals -8. You should plug it back into your denominators. Does that make any of your denominators equal 0? No? It makes them equal -8. So you're good. Okay. Any questions about that? What that means for us, if we're looking at those first 3 fractions in the original problem, what was your LCD, your least common denominator, was 4x. Like if you were going to try to add all these things together, you would get a denominator of 4x in each of them. Okay, so what you choose to multiply by, that becomes, or that was really your LCD. Instead of finding the LCD first, I just do it one step at a time. First cancel all the first factors that you need, then the second ones. Okay. Let's try another one. 1 minus 8 over x minus 5 equals 3 over x. And again, when I write this down, I would write it with lots of space for myself. So as I'm copying it into my notebook, it will look something like this. That's nice because then I don't have to try to squeeze everything super tiny. Note that that very first term is a whole number 1. Does 1 have a denominator? What is its denominator? 1. It's really like 1 over 1. Do we have to worry about multiplying everything by 1? No, because then it's just the identity property and it's just itself. So anytime you have like a number term or maybe like just an x term with no denominator, it does have a denominator of 1, but we don't have to try to cancel that because that will always be true for everything. So I would skip over my first term and I would go to my second term. What am I going to have to multiply by to get rid of x minus 5 in that denominator? I'm going to have to multiply by a whole x minus 5, right? Think back to section 7.3 when we were doing simplifying, multiplying, and dividing. We had to factor everything, and common factors in the numerator and the denominator could cancel. So the only way for us to get rid of this x minus 5 is to multiply by x minus 5. Yeah, Kylie.
You can multiply by just the x first and then cross out the x with nothing.
No. Like this. And you would have multiplied it by x, right?
Yeah.
And you would have had like minus 8 times x. No, so like if you were going to cancel out these x's right here, that's what I would call getting cancel happy. Why are you not allowed to cancel that x? It's not a factor, it's a term in a factor, right? This x in the denominator has a plus or minus right after it. And if it has plus or minus right after it, you can't just cancel it with a single x. It doesn't have a factor of x, it just has a term of x. So the only thing that will cancel out x minus 5 is something that looks exactly like that above it. X minus 5. The same could be true over here. Will this x in the denominator cancel with the x in the numerator? No, because this x minus 5 has a term x, not a factor of x. So what will I still have to multiply by? X. Okay, I'll have to multiply everything by x as well. Then I can cancel out those lonely x's. So if you're thinking in terms of like LCD, least common denominator, your least common denominator was really that x times x minus 5. You have to have a factor of x, and you have to have the factor x minus 5. X minus 5 does not have a factor of x. It has a term of x. Now, be very careful on this one when you write what's left over. There's distribution that happens. In this very first term, you have 1, which sort of we can ignore, times x minus 5 times x. So I can really distribute that to multiply it together. That's x squared minus 5x. Are we okay with that? You should multiply things together that are left over, so actually distribute them if you can. Then I have a minus 8 times x. That's just minus 8x. Those things were left over in the numerator. And on the other side, I have 3 times the quantity x minus 5. So I'm going to, again, multiply those with distribution. Anything that's in parentheses, you should distribute into that. So that would give me 3x minus 15. Well, this one maybe doesn't look as nice as the other one once we simplified things. It's still better because it doesn't have the fractions. So now I just got to clean stuff up. Like I can combine the minus 5x and minus 8x to get like terms for a total of negative 13x. And now when I look at my equation, I see that I have x terms and I have x squared terms. So I'm going to need to make one side equal to 0 so that I can try to factor it. I would subtract 3x and add 15 to both sides. So that I have x squared minus 16x plus 15. Remember, you can't factor until one side's equal to 0. And then, do you have factors of positive 15 that add to make negative 16? Justin, you're saying yes. What are they? Yeah, negative 15, negative 1. So we'll factor it out as x minus 15, x minus 1 equals 0. The negative 15 times negative 1 is positive 15. The negative 15 plus negative 1 is negative 16. And x equals 15 and 1. You should do what? Check for extraneous solutions. If you go back to your original problem, your denominators are, I think, x and x minus 5. Does plugging in a 15 or a 1 make any of those 0? No, so we're good to go. Okay. Those are both of our solutions.